Mass movement contains mass movement, types of mass movement, factors affecting slope stability, preventive corrective measures. Mass movement, mass wasting or mass movement is defined as the downslope movement of material under the influence of gravity. Takes place when driving force acting on a slope is greater than resisting force. The resisting force is due to the shear strain of the slope material. The driving force is the component of the gravitational force acting parallel to the slope. Landslide or mass movement. Landslide is the movement of mass of soil, rock, or debris down slope along a plane of sliding. According to Selby, the mass wasting is more inclusive than landslide because the latter doesn't include falls, topples, creep as they don't have distinct plane of zone of sliding. Mass movement are classified according to the dominant material, water or air content and velocity of the movement. Landslide classification system by DJ Barnes. Falls. Falls are abrupt movements of masses of geologic materials that become detached from steep slopes of cliffs. Plane failure, downward movement along the planar surface. Planar failure in rock in which a discontinuity daylights the slope face. Wedge failure. Wedge failure on two intersecting discontinuities with a line of intersection which daylights the slope. Debris flow. Toppling failure. Rotational slide. Rotational slide is one in which the surface of structure is curved concavely upward and movement is more or less rotational about an axis about the slope slide. This is the landslide occurred on September 10, 1978. Note that a road bridge has been destroyed and the material has almost blocked the Tino River. The present slide is a part of a much larger fossil slide December 1978. Translational slide is where the detachment of mass is along a planar surface. Earth spread debris flow. लिउ खोला खरानी खोला ल्युटी creep 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 is the slow down slope migration of soils and loose rock fragments resulting from a variety of processes including frost heaving. It is indicated by curved tree trunks, bent fences or retaining wall, tilted poles and small soil ripples. Factors affecting slope stability: geological discontinuities, water, geometry of slope, geotechnical parameters, dynamic forces, erosion, vegetation cover, anthropogenic factors. Geological discontinuities. Discontinuities like joints, bedding planes, foliations, fractures control the type of the failure. Orientation of discontinuities with respect to slope determine the stability. So here is a three figures showing which one is unstable and stable. Closely spaced joints give low cohesion of rock material and cause instability, circular failure. Roughness of discontinuous surface increase the friction thereby the resisting force to sliding. Persistence of joints defines the size of block that can slide down. Effect of water, groundwater generates poor water pressure. Precipitation seeps through surface and generate water pressure along slope. Water pressure in joints reduce normal stress, hence reduce shear strain. Water add load to the mass, making it unstable. Water also cause uplift uplift force at the surface between the unstable block and surface. Geometry of slope. Height and angle of slope also affect the stability of metals. Critical slope height depends on shear strain, density, and bearing capacity of slope metal. Slope stability decreases with increase in height. With increasing slope angle, the tangential stress increases. Increase in shear stress, thus reducing its stability. Geotechnical parameters include shear strength, particle size distribution, density, permeability, plasticity, angle of repose, etc. Friction and cohesion directly is related to the stability of the metal in slope. Coarse metal will have greater opposing frictional forces or shear strength to resist the moment. Permeability of the soil affects seepage pattern and water level. Angle of repose of loose metal is influenced by the size and shape of its particle. Coarse fragments can maintain a greater slope than fine fragments. Dynamic force. Forces like earthquake can trigger small to large mass movements. The tremors can cause co-seismic detachment of rock soil mass from slope face. Seismic waves can cause fracturing in rock and dislodge a rock in future. 1,000s of landslides were reported after 2015 Gorkha earthquake in Nepal. Erosion. The scouring or cut of the toe of slope can trigger mass movement. Localized erosion by groundwater surface runoff can decrease interlock between adjacent rock block, decrease shear strength. Erosion can increase permeability, thus affecting slope stability. Vegetation cover. Roots provide interlocking network to hold unconsolidated metal together and prevent flow. Plants provide cover to the ground, helping to reduce surface runoff and erosion. The loss or removal of slope vegetation can result in either increased rates of erosion or higher frequencies of slope failure. Nevertheless, presence of vegetation only is not enough to prevent mass movement. Anthropogenic factors. Disturbance of natural slope by man creates slopes instability. Hap- haphazard road construction is one of the major causes of slope failure. Mining works can also cause slope instability. Development of infrastructures can cause mass movement in unstable slope. Reservoirs can be used of slumps and slides. Causes of landslide. Weak and sensitive geological metal, weathered and shared metal, jointed and fissured, adversely oriented discontinuity, contrast in permeability, contrast in stiffness, fluvial erosion, deposition of load on the slope, vegetation removal, intense rainfall, prolonged precipitation, rapid snow melt, earthquake and artificial vibration, freeze and thaw weathering, volcanic eruption, mining. Mitigation of mass movement, surface water drainage, groundwater drainage, rock anchors, rock nets, pile works, retaining structure, and bioengineering susceptibility study. So, this was for today, guys.